Now, in an as yet unpublished paper, Anouk Barberousse and Cyril Lambert have noted that the representation of lattice gases and lattice fluids would not have been possible without the development of cellular automata as representational devices. Because the representations of cellular automata are non-linguistic, this means that the issues explored by Friedman perhaps can be extended to non-linguistic frameworks of that kind. It's true that one can represent a Turing machine using a two-dimensional cellular automata, so that a binary language is representable on such a cellular automata, but the binary states of the cells do not themselves count as a language. Rather, the states of the cellular automata that are used in representation of lattice gases represent the state of the system directly. So I think these representation schemas and the basic issue, without those representational devices, you could not even begin to frame the theoretical apparatus with which you want to represent the systems, carries over from linguistic to, in some cases, non-linguistic examples. Now, one of the important features of Friedman's position is the way that it accommodates changes in constitutive a priori principles. This is in contrast to the traditional account of a priori principles as being fixed. Now, in a different way, the account that I gave in Extending Ourselves of the moving boundary between the realm of the observable and the realm of the unobservable is designed to capture the fact that our scientific ontology is discovered by progressive expansions of the realm in which science has contact with what exists, rather than drawing, as the traditional empiricists did, a fixed line that is grounded in human perceptual abilities. So what I want to suggest is that there's a second dimension of the dynamics of representation, a dimension along which the representational apparatus is progressively expanded in ways that, analogous to breaking the ties to human cognition in the perceptual realm, they're no longer tied to human cognitive capacities. Now, Friedman was understandably concerned with the question of whether a rational evaluation of revolutionary transitions in science was possible. The famous problem of incommensurability is, of course, associated with scientific revolution. But it's a more pervasive problem than that. The problem reappears at different scales when new conceptual frameworks have to be introduced in order to effectively represent the phenomena at a new level of theoretical representation. And I'll just mention off to the side that this is precisely the issue that's involved in some forms of emergent phenomena in which a reconceptualization of the ontology is required in order to effectively predict and represent the phenomena, for example, in condensed metaphysics, as opposed to high-energy physics. Smaller scale theories can be incompatible with larger scale theories. Smaller scale theories can be as incompatible with larger scale theories as can different theories on either side of a revolutionary divide. Okay. So now let me just finish with a problem. It's that. Now, there are people in this room who have far more expertise in intentionality than I do. But I'll just explain why I sort of raised this at the end as a sort of issue. I would like, as much as possible, to stay with the kind of formal representation that I mentioned. I think you can borrow ideas from Michael Friedman's account of the role that these plays as a necessary precondition for representing certain phenomena, and use those as a transition point to trying to understand what the conceptual frameworks that computational devices use. Now, there is, as I mentioned during my talk, some body of work emerging on non-conceptual content and related areas. Some of this is fairly successful in robotics. Whether it's extendable to higher cognitive functions and sophisticated representations that you find in physics of the kind that we would like to have for metaphysics, I really do not know. There's also the separate issue, and I mean, Ron Geary here is somebody who would defend that view, that you can't even satisfactorily represent the modeling relation without bringing in a cognitive agent, and that cognitive agent almost certainly is going to have some sort of intentional interpretation of the apparatus. So I just state this as that there's a whole range of problems here with which one is going to have to grapple. I don't in any way pretend that they're easy or even that they might be successful, but one has to think about them, I think, in order to try and understand where things are going in these sciences that are now dominated with these kind of computational methods. Okay, so I'll stop there and go sit down.